The Landing Distance Analysis tool was added to the Flight Data Viewer in May 2026. Let's jump right in and demonstrate how it is used. This tool will work with any EFIS that records GPS and vertical speed data and is supported by the Flight Data Viewer. Since this tool measures your landing distance, it is important to fly a stabilized approach on final. That will improve the accuracy of the calculated results. After the landing roll, you must come to a full stop on the runway for at least 2 seconds. The stop must be on the landing runway and not on a connecting taxiway. At least one recorded data sample must contain a 0 GPS ground speed value. Additional test flight planning suggestions will be provided at the end of this video. After the flight extract the recorded data from the EFIS SD memory card and display the flight. Next, you need to find and select the data recorded for each landing. The easiest method is to view the altitude graph. This flight includes 10 landings. Each can be easily identified by the loss of altitude, followed by a region of constant altitude, which is the ground roll and subsequent aircraft taxi. Click your mouse on the graph at a point where the altitude is at least 50 feet above the ground roll. Next, hold down the Shift key and click the mouse at a point past the end of the ground roll. The selected range is shown by 2 vertical lines on the graph and by the blue highlighted rows in the data grid at the bottom of the screen. It is recommended that you verify that at least one of the selected rows contains a 0 GPS ground speed value. Scroll the selected rows downwards until you see a row with 0 ground speed. Next, save this range so that you can quickly retrieve it later. Press the F2 key. Enter a descriptive name for this range and then select the type of landing. You can also invoke this function using the menu by selecting Ranges. Create New Range. Repeat this operation until all the individual landings have been selected and saved. Now run the landing distance calculations for each landing. Hold down the Shift key and press F2. A list of previously saved ranges will be displayed. Double-click on a range's name to select it. You can also display the list of ranges using the menu by selecting Ranges. Select Range. Make sure that the altitude, air speeds, vertical speed, or flight path data is currently displayed. From the menu, select Analyze, then Landing Performance, then Calculate and save landing performance for current range. The calculations may take up to 30 seconds to run. The algorithm must scan through a large database of airports and runways. The results are shown here. As you can see, the landing distance ground roll and total landing distance over a 50-foot obstacle are shown. In addition, the runway elevation, density altitude, outside air temperature, airport, and the runway used for the landing are displayed. You should fill in the aircraft weight, flap setting, wind, conditions, and runway surface type, since these factors affect the landing distance. Saving these values now will allow you to later compare how different environmental factors affect landing distance. This will be demonstrated in a bit when we display the list of previously calculated and saved landing distances. Optionally, fill in any notes that will help you interpret these results later on. Click the Yes button to save these results. Repeat these steps for the other landing ranges. To view the list of saved landing distance calculations, from the menu select Analyze, then View Analyze Landing Performance Data. The list of landings is shown here. Data for each landing is displayed. The landing distance to a full stop is shown at 3 points, from a 50-foot obstacle, from the flare, and finally the ground roll distance. Note that the values for the distances over the 50-foot obstacle and flare will be more accurate than the values for the ground roll distance. This is because there are no significant changes in the data after the flare that will positively indicate that the ground roll has begun. Data can be sorted and selected in many ways. For example, let's assume you want to only view landings with a 30-degree flap setting. Click on the label at the top of the Flaps column. This will sort the rows by the flap setting. Clicking the label again will sort the rows in descending order. Next, unselect the rows that did not use 30 degrees of flaps. Now click the Print or Print Preview button to view the report. Note that only the selected rows are included in the report. As the pilot, you're responsible for designing your landing distance test plan. The Flight Data Viewer only performs calculations based on the data recorded by your EFIS. As you plan, keep in mind that landing distance is affected by flap setting, RPM, density altitude, primarily determined by outside air temperature, wind, aircraft weight, runway surface type, and type of landing, 3-point or wheel landings. Therefore, your test plan should attempt to account for as many of these factors as possible. Make a plan, and only then start to gather data. The Flight Data Viewer will do most of the difficult data gathering work, but you'll need to manually record the aircraft weight, wind conditions, surface type, and landing type. If you're set up for audio recording, take advantage of that by recording the automated weather transmissions to save the wind data, and reciting aloud the flap setting and any other important configuration data. If at all possible, repeat each combination of landing factors at least 3 times to minimize errors introduced by your EFIS. If you have any questions, please email us. Have fun and fly safe during your flight testing.